This video will be about converting the polycurve output from canbam into a Nurbs entity and why you might want to do so. Canbam is a great program and is capable of making the G-code for machining the different parts of the hypocycloid gearbox. But if you want to analyze or modify the cam profile, it is easier to do in Rhino because canbam has pretty limited drafting capabilities. The other big advantage Rhino has over canbam is the ability to turn the cam profile into a 3D object made of surfaces, and once you have the surfaces, you have the option to use other cam packages to generate the G-code. The reason you might want to use software other than canbam is increased flexibility you have in generating the G-code, along with the possibility to do a 3D simulation of the toolpath instead of just a backplot in canbam. One problem with using the unedited output from canbam is that it is made up of a bunch of line and arc segments, and when you extrude them, they generate a bunch of surfaces that make generating G-code in other programs difficult because of all the surfaces you have to deal with. A good way to fix this shortcoming is to import the polycurve from canbam and convert it into a Nurbs curve in Rhino. Once you have the Nurbs curve, you can turn it into a surface and then extrude it, and the result will be one big single surface that is much more manageable. Another advantage of converting to Nurbs is that the resulting curve will be much smoother than the polycurve from canbam. In Rhino, you have the ability to analyze how smooth the profile is or the degree of tangency between the segments. This is the curvature graph and is used for analyzing the amount of curvature in a curve. The way it works is by representing the amount of curvature by drawing lines outward from the curve, and the length of the lines indicate the amount of curvature. A longer line means more curvature. Whenever you see a step, it indicates that the segments of the curve are not tangent or not a smooth transition between one another. One way you can fix this is to convert the polycurve into a Nurbs curve. In reality, this lack of tangency causes a very small amount of error, but since I needed to convert it for the purpose of consolidating surfaces, I figured a small increase in accuracy was an acceptable byproduct. Now I will show the curvature graph for the polycurve made with different max segments values I tried for the hypocycloid plugin, starting with 500 and ending with 10K. The last one will show the curvature graph for the converted Nurbs curve. This is the curvature graph for a setting of 500. It doesn't display anything because there are no arcs. It is just straight line segments. This is the curve graph for the setting of 700, and there are only a couple of curves right across the zero pressure angle. At 1K there are slightly larger curves. 2K even more, and now you can start to see the steps between the arc segments. At 10K the whole line is covered with lines, and it shows that it is all arcs and there are no line segments. And the last one will show the converted Nurbs curve and how much more smooth the curvature graph is. Before I converted the profile, I wanted to make sure that it would be as symmetrical as possible, so I isolated one half of the lobe by using two lines rotated by 4.5 degrees, and then used these lines to trim the profile. Next, I used the mirror command to make a full lobe. Now that I had one full lobe that was symmetrical, I selected it and used the rebuild curve command to convert it into a Nurbs curve. The final step to turn the profile into a 3D model is to use the surface from Planar Curves command to generate a 2D surface and then extrude the surface with the extrude face command. Now when you explode the model, you can see that it's just 3 different surfaces. It's got a top, a bottom, and the side. This makes it much easier to work with in other CAM programs. By comparison, I'll show the 10K setting. This is the 10K setting, and as you can see, the side is made up of a lot of small faces. This makes it much more difficult to work with. The description I gave does not show the center hole or output holes in the cam, but the workflow is the same when they are included.